Can you hear us now?
Take a second to catch up.
Can you hear us now? Yes, there we go.
All right, let's try that one more time.
Okay, starting over from the top. Sorry about that. Okay. Right, awesome. So our first question was from Jesus. He was talking about strings and using them in code. He asked, when you're teaching us about concatenation of strings, and you use the first name, last name example, we added a space in the output string, and if we could have included this space as a variable in the code, right? So we absolutely could have. Right? We could have done something like variable name equals quote space quote, and that's it. And then we could have used that variable name instead. So this would create a variable with the value of a space, which is just empty looking, right? But a space is a character itself. Jesus goes on to explain that the spaces inside of the code itself seem to be ignored. So what's actually happening here is that the Python interpreter is taking apart the source code, and it's mostly ignoring the white space in source code. So white space in source code includes things like new line characters, tabs, and spaces. These are things that don't show up. They're not interpretable characters in most cases. So it might see something, if we type something like variable equals no quotes, a bunch of spaces, and then quote something else, end quote, it'll ignore the quotes in between the equal sign and the value in quotes, because that's not interpretable code. But as soon as it hits that quote mark, it says, oh, I'm starting a string. I'm going to take whatever's inside that string, which also might be spaces, and interpret it that way. So Phil, you want to do a little demo?
Yeah, let's try a little demo here. Let's try to share the screen here and see if you can see my Python REPL. So to that first question, could we store a string in a variable, a string that contains only a space in a variable? Absolutely, we could. We could have a variable called A and store in it one space. So it's an open quote, space, close quote. Now, if I just try to display this, you'll see that it's just a single space. If I say something like print hello plus a plus world, and you'll note there's no space at the end of hello after the comma, and no space before the W. But that A, which contains a space, gets concatenated in there. And so I get these three strings concatenated together with that space string in the middle. That second concept, if we were to say something like print hello plus as many number of spaces as we want, world, you'll notice that in the context of that Python statement, those spaces are ignored. But if those spaces were to be inside of a string, so it's interpreting the space in two different contexts, right? There's a space in the context of a string, which is just another character, even though it renders sort of invisibly just as a horizontal space. And then there's a space in the context of some Python code. And as Ryan was saying, Python is very flexible when it comes to these spaces within the code. It tends to ignore them, whether they're spaces or tabs or even new lines. And it just renders the content of the statement without any regard to the spaces.
And this happens because the Python interpreter is pulling apart what we type in and looking for keywords, which are things like print, which are things like well, actually, we haven't seen many of them, but it's looking for variable definitions, it's looking for variable names, it's looking for the operators, and it's trying to ignore everything else. So you have a lot of flexibility in your expression of these things, but it's just looking for the most important parts that it needs to interpret.
Right. So just one other point, there's nothing magical about this effect in strings. The same thing would be true if we were using, say, for instance, integers. I could put a bunch of spaces in here, and it doesn't really matter. It still evaluates 3 plus 5. So one of the things that might be confusing is if you're looking at Python statements like a equals 3 plus 5, this is a Python statement. It's an instruction to Python to do some work. In this case, add 3 and 5, evaluate that to 8, store the result in the variable a, which we can verify. It is not a string. If I were to place this in quotes, so let's say I place this in quotes and I make this 10 and 5. That's simply a string containing an a, a space, an equal sign, a space, a 1, a 0, a space, a plus, a space, and a 5. It didn't instruct Python to do anything. So there's strings, which are just data. It's just a collection of characters in an order. And then there are statements, which are telling the Python interpreter to do something. And those may include strings.
Awesome. Now we've got a question from Mr. Canavet. Can you cover when to use a plus versus a comma in the print function? So what the difference here is we're doing two different things for the print function. So when we use the plus, we're interpreting that we say a. In this case, we defined a as a string, and we were using that in the print function. When we're using a plus, we're using that plus as the string concatenation operator. And that actually all evaluates before the print function, before it's passed to the print function. So it makes the string using a plus and then passes it to the print function. Now, a comma is using the operator behavior, or not the operator, the parameter behavior of the print function, which we'll look at in detail a lot more in the next week. But basically what this does is it says anything that you include in between parentheses with a comma in the print function gets automatically separated by a space. So this is a little weird thing, and there's no real difference between when to use it. It's entirely a style thing. I think it's a little clearer to use the string operator, the plus, but that's my opinion. What do you think?
I like the commas if the commas work. It seems to me to be less overall code. The big difference, and you pointed this out, is that the plus sign is an operator, and so it's part of an expression that's causing the computer to do an evaluation. So if you're plussing some strings together, let me pull up this Python REPL again. So if you've got a string ABC and plus XYZ and plus 1, 2, 3. So this is an instruction for Python to evaluate this expression. And the result of evaluating this expression will be a new string. In this case, the string containing A, a B, a C, an X, a Y, a Z, a 1, and 2, and a 3. And when you're using the print statement with commas, what this is, and we'll talk more about this when we get into later sections of the course, is a list that we're giving the print statement. And it's a list of strings that we want the print statement to print. And it's going to be a different output. So if I plussed the string ABC, XYZ, and 1, 2, 3, if I concatenated those strings together, I get a single string that has all of the characters in those three strings And notice there are no spaces. But if I use the comma to give a list of strings to the print statement, it outputs them with spaces in between them. So the behavior is a little bit different.
Yeah.
When you want the spaces there, I find the commas a little easier to work with than to manually put the spaces in there. I find the commas a little easier to work with than plussing with manually putting the spaces in there.
Is it possible to use both spaces or the commas and addition in the print statement?
It is. So we could do something like this. Let's do it. So in this case, again, I'm giving a list of strings to the print statement to print. The first string in the list is going to be evaluated from this expression. So it's going to concatenate ABC and a space and XYZ. And then the second string in the list is just 1, 2, 3. And so it will separate those. And you get a similar result that you have up here. So I think the best advice is to play with them and find out what each does, and then use them when it makes the most sense for you to use them. I don't think there's a right or a wrong answer.
Yeah. Yeah. And again, like these are style choices, and this is going to lead us right into our next discussion. These are all style choices, and it's about choosing the right way of expressing code in terms of how clear it is, right? So you want to be as clear as possible as to what's going on. If that means using the comma instead of the addition operator or the string concatenation operator, then do that. If it's the other way around, then do that. Whatever looks to you like it will be the most clear to somebody else reading it, do that. And there's no hard and fast rule for a lot of this stuff besides make it clear. As you code more, these kind of choices are going to become more obvious into how these things work and how it puts together. Okay. Our next question has to do with how our programmers use variables and name variables. So in this case, Jesus again asked if there's a style difference between using underscores between words, like we did first underscore name in our examples, and then some other people might do it as all one word, so it's lowercase f first squished together with uppercase N name and stuff like that, right? That's what's known as camel case. There's a lot of examples of different ways of doing this sort of thing. And really what it comes down to is there is consistency is most important first off, right? If you're going to do something, use a consistent style in the code that you write. Secondly, the standards for this type of thing, these styles vary, they try to maintain consistency across communities, right? So a whole language is a kind of community. So Python has its own style, which tends to favor underscores. Java has its own style, which tends to favor camel case, which is where the increase in case separates words and things like that. We're going to show you a couple of examples right here. So we've got camel case, which is the Java representation. Pascal case, Pascal case capitalizes the first letter in the variable name, and Python tends to favor the underscore representation as well. So this will also change inside of other communities. So if you're working for a company, they will have what's called a style guide. Those companies have a big style of basically rules for consistency. They want all of their code to look the same, so it's easy for any programmer to read any other programmer's code without having to sort of spend any extra cycles thinking about how to interpret it or anything like that. We're actually going to give you guys a style guide when we get into the Java part of the class, when we get a little bit more complicated, and you'll see some of the rules and some of the types of rules that we stick to. And remember, these are guidelines. the style guides are there to help enforce consistency and readability. If you get to a situation where the style guide is forcing you to be to make something that looks more confusing to you, don't do it. Right? Again, these are guides. They're not rules. They're not hard and fast rules. So remember, clarity is key when it comes to things like that.
There's also a question about tabs versus spaces in the formatting and coding conventions. Specifically, this comes in, I think, we'll see a lot more examples of this when we get into the section on functions and structured programming. There are some times where you want to precede a line of code with a number of spaces. We want to indent certain things to make the structure of the code more clear. And you'll run into, again, kind of community-based divisions here, where some communities will always use tabs of a fixed width to indent their code, and other communities will always use, say, a set of 4 spaces per indentation level. In Python, it becomes particularly important, especially those indentation levels, that they are consistent. And it may be the case that a tab and 4 spaces look identical, but a tab and 4 spaces are considered very different things to Python. And what Python requires is consistency, and that's something you should aim for no matter what. So if you're indenting your code with tabs, always indent your code with tabs. And if you're indenting your codes with spaces, always indent your code with spaces.
Okay, so what we got most requests for this week was to go over some of the challenges, particularly the practice challenge, machine head. It seems like a lot of people were confused about that, and it's definitely part of that confusion is our fault. We had misordered some of the material here, and we were relying on you to use some operators that we hadn't introduced yet. So what we're going to do is we're going to open up Evoke RAM ourselves and go through this challenge and our approach to how we would solve this particular challenge ourselves, right? Yeah, I'm going to go to configure workspace.
Okay.
Cool.
And then share.
Yeah, have you done this one before?
I might have.
No, not yet. Awesome.
Okay. So this is what they get to start with? No.
That's what, no, that's the template that I was using.
Okay. So this is what we want to start with, right?
Yeah, that's what we want to start with. Okay,
So
cool.
Well, just application.
Sweet. All right. Okay. So with this challenge, the idea was we're going to switch keyboards here. Go over. Awesome. Perfect. Okay. So in this challenge, the idea was to take a size, right? So a size is going to be given by the testing program. And we want to say, based on this dimension, which of the 3 cutting head sizes is going to be smallest. And we have a circular cutting head, we have a rectangular square cutting head, and we have a triangle cutting head, right? So for these, the way we might work this is we would take something like each of these pieces, and we would first calculate the area, right? So we're looking at the total hole size for these. So something like, can you click in the editor for me? Awesome. So we might do something like, I want to calculate the area for each of these. So I might say something like circle area equals, it's going to be the size. We'll take the size as I believe it's the diameter, or is it the?
I don't think it specifies.
Okay.
So it leaves some things for you
Oh, it's
to...
the biggest dimension is the same for all 3 shapes. Awesome. Okay, sweet. So that makes sense. So for this case, the circle area is going to be the diameter times pi times, it's going to be pi times the diameter squared. Half the diameter squared?
Half the diameter is the radius.
I thought it was 2 pi r. No, that's
Pi r squared.
it's pi r squared. Okay, awesome. So we'll take pi, which is 3.14, and instead of making this a magic number, I might make it a variable or something like that, and I could provide more digits, but it should make a huge difference here. Times the diameter, which in this case is the variable size, divided by 2. That gives us the radius, and then I want to square it, right? So that gives us the first area. The second one is the triangle, right? So I'll do triangle area is equal to, now in this case, the biggest dimension will be probably the side of the triangle. So it's going to be one whole side length to get that'll be the base. So for a triangle, the area is the base it's height times 1/2 of the base, or
1/2 base times height. Yeah.
1/2 base times height, right? So we can take size as the base, so we'll divide that by 2. Can you enlarge the screen? Can you zoom in a little bit?
I think so.
Oh, that's me. I can zoom.
Oh, too far.
Woo! Awesome.
Better?
Yeah, I think that's better. So that's base times height, which is, or sorry, is that base times height? Height is something else.
Yeah, it's gonna depend on what kind of a triangle it is. If it's an isosceles triangle.
Yeah, I think we said it was an equilateral triangle. Yeah.
In that case, there's a formula for it.
Yeah. Let's do. So Phil is Googling. We're gonna hold this one on hold. We'll just say something here. So he's doing a little bit of research for me, and then the simplest one is the square area, which is equal to the size times size, which is basically just size squared, right? Awesome. Okay, so A is one side. Okay, so for an equilateral triangle, the area of an equilateral triangle is the length of a side times the square root of 3 divided by 4. The length of a side squared. So it's size squared times square root of 3. So we could
3 star 0.5.
Yeah, 3 star point 0.5 divided by 4. Right? Yes, that should work. Okay, awesome. Now, here comes the expressions, and this is, so we just Googled that, and it's the area of an equilateral triangle given the size. So now we have these 3 areas, and we need to compare them and put them in variables that make sense, right? So the circle least variable is our output variable, and that should be true or false. It should be true if the circle area is less than the triangle area and it's less than the square area, right? Now that and, where I just said and, was where we screwed up, is we forgot to put and explain about logical operators before we gave you this challenge, right? So that's totally on us. Some of you stuck with it and you looked at, gathered some extra information and dug into it and found logical operators in the very next section and went back and did it, which is awesome. That's fantastic that you guys persisted. But if you were confused and got stuck there, this is why. It's because we left something out. So basically the thing I want to say in this particular example is circle area is least if, or circle is least if the circle area is less than the triangle area, and the circle area is less than the square area, right? So that expression should give us the circle area is the smallest, right? Similarly, triangle least is going to be the triangle, going to be true if the triangle area is less than the circle area, and triangle area is less than the square area. And finally, square least is true if the square area is less than the circle area, and square area is less than the triangle area. Now, let's hope that this works. So if you go ahead and hit run for me, yeah. Nope, size is not defined. Oh, I used the wrong variable entirely. It should be dimension. So if you will click into, you want to select those for me? Oops.
Oh, yeah.
Yeah. Try that again. Up. I got all three right. Okay, so that's how we solve that problem. How I solve that problem. And I'm sorry to everybody out there for confusing you. We'll rearrange the course a little bit. This is the first run of the course. So thank you all for your patience and for your persistence on helping us solve some of these problems. Next, I'm going to turn it over to Phil, and we're going to look at some of the project challenges and see how those work, how we solve those.
Well, where's this thing? Down here.
Yeah. That's the one. Nope. So you're starting on hard. The pull down is up at the top if you want to start on the easy one.
Thank you. I'll always start with the easy ones. That's my best advice. All right. So this says write a program to determine your car's gas mileage. You should use the input variable miles traveled. And gallons fuel. And the result should be stored in the variable miles per gallon. The testing system will place values in each of the input variables, evaluate your code, and then the result will be checked for correctness. So I need to use miles traveled and gallons fuel to determine what value should be stored in miles per gallon. Per usually means divided by. So my first attempt would be something along these lines. Miles per gallon equals miles traveled divided by gallons used. And then I should be able to run this. And it passed. Of course, this is the easy one, so. And this is my second time doing it, so I feel pretty confident. My approach there is, as I'm reading through the problem specification, to try to pull out the pieces that I think are going to be part of the code when it's naming the variables that I'm going to be using and the variables that I'm going to be storing a result in. I can start to piece together some of those statements and some of those expressions, and that helps me keep track of things. And that worked pretty well. So should we go on to one of the medium ones?
Yeah, let's skip to a medium one. unless we get a specific request.
Should we do car loan or sphere packing?
Let's do car loan.
Let's do car loan. That sounds like fun. Get rid of my experimental code here.
Yeah.
All right, so let's read through this. Write a program to determine how many months it will take to pay off a car loan with interest. In this challenge, you must choose your own input variables. Variable names, design your own test to verify the program operation. This is a lot of work. The output value should be written into a variable called payoff months. When you click the run button, your program will be executed and the value of payoff months variable will be printed below. Okay. So I would need to know, and I don't generally keep this information off the top of my head, how to calculate the number of months to pay off a loan of a particular, with a particular interest and for a particular principal. But I do know that interest is going to be part of it. And there's going to need to be a principal. That's the amount that the loan is being taken out for. And I'm going to have to supply my own values here. So let's say 5% interest and a principal of, are we given in the instructions?
Yeah, there was an example. We said
there is. It's 4% interest, isn't it?
4% interest and a
10,000. So a principal of 10,000 and an interest of 4%. At this point, I'm going to have to do some research and find out what kind of formulas are used to calculate these kinds of results from these kinds of inputs. And I've done that. And what I found is I couldn't reasonably do it without a log.
Mm-hmm.
So that's available to us. This is something that we haven't covered yet, and we will soon. But most programming languages include a handy library of additional features and functionality, and Python is no different there. And one of the little features that they provide is a math library, which includes a log function. So I can import the log function from the math library in Python, and this will allow me to do logarithms. Now, the formula that I found looks something like this. The number of months is equal to the negative log of 1 minus the interest times the principal divided by the payment. And we didn't determine what the payment is yet, did we?
Nope.
So I have to provide a payment here. So let's say that the payment is going to be $100 per month. And this would be all over the log of 1 plus the interest rate. So, and here I'm using the variable names that were provided in the formula that I found by doing a little bit of research, and they were using A as the principal, and P as the payment, and I as the interest. But I ran into an interesting thing that interest is usually expressed as an annual rate. But if the payments are going to be monthly, we're going to need to know the monthly interest. which is simply the annual interest divided by 12 months in the year. So this was the monthly interest. This is the principal. This is the payment. I should be able to put this together. Now, I can't put together an algebraic expression like this here, so I have to flatten this out and make it linear. So it's going to be something like n equals the negative log of 1 minus I times A divided by P, all divided by the log of 1 plus I. And then I can go ahead and fit my variable names in here. So for me, N is payoff months. I is monthly interest. A is the principal. And P is the payment. And then this should work. So my payoff months is going to be the negative log of 1 minus the monthly interest times the principal divided by the payment all over the log of 1 plus the monthly interest.
I think you're missing a parenthesis.
Let's see. Yes, I am. On the top half of the equation here.
Yeah.
Let's just see what would happen if I run it without that parenthesis.
Awesome.
Unexpected into file while parsing, and it's pointing to the end here, even though that parenthesis is missing here. So it found a syntax error there, and it knows something's not right, but it just doesn't know quite where it's not right. So I would have to look through there, and actually, I'm missing one here.
That's the one I spotted.
I was missing two. I was missing the one on the top and the one on the bottom. Technically, I probably don't need them, but I kind of like to package the top and the bottom expressions separately. It makes it a little more readable. So now if I try to run this, it says math is not a package.
Is it capital M?
I don't think it is.
No.
No. Is it not going to let me import it? Oh, hold on, let's try math.
There it is.
Okay, so this runs. I don't know if it's producing the right output or not. Let's
About
find
10
out.
years. It looks like a little bit over 10 years to pay off a $10,000 car with $100 payments and 4% interest. That sounds about right.
Yeah, and I can go to an online payment calculator and punch those same numbers in and see if I get a similar result. And I do. So that's reasonable, I think. That's a tough one.
Yeah, so this, we were just talking about this in the chat room, that this approach is more complicated than we intended. We did not absolutely expect you guys to implement this complex logarithmic based one. We were just hoping for a simple interest calculation, which actually, Phil, what would that look like instead if we just did simple interest?
So that would be if we just did simple interest without compounding interest.
Yeah.
Then we would calculate the interest on the principal. So if it were going to be it would be the equivalent of like a one-time interest payment. So 4% of 10,000 would be 400, right?
Mm-hmm.
So the total payback amount would be 10,400, and the question would then just be, how many times do we have to pay $100 to pay back that 10,400?
Yeah.
So it's a much simpler expression, and it would look something like this, I believe. That would be the principal plus the principal times the interest. That would be the total amount that we have to pay back divided by payment would tell us how many payments.
Yeah.
So if I comment this out for right now. And try this.
Yeah. So your payoff is now 104 months. So compound interest makes a big difference if you're doing this sort of stuff. But yeah, we intended simple interest. This was something that we did not clarify in our instructions. We'll make sure that that's included the next time this goes around. Something that has been brought up in the discussion here is that we're making you do a lot of math, right? And it's absolutely on purpose, because programming by itself is got its roots in mathematics, but what we're trying to do here during these first few units is get you really used to writing lots of expressions. And expressions at this point are things that are related with mathematical operators, that are related with the comparison and logical operators, the relational operators, and stuff like that. So we're taking advantage of these mathematical tools to get you to go and do some research, which is really a huge part of what actual programmers do, and integrate that new knowledge into solving the problem, right? So a lot of times, even Phil and I, when we're working on a problem or working on something, we're, like you said, like you just saw us, we're going out and Googling stuff all the time. We're figuring out what extra information is available for us to actually help us solve these problems. And it's super common. We want to give you guys that experience. It's definitely, this part is on purpose. We want you to have to go and find extra information, because that is a very, very real part of programming and of problem solving in general. Okay, so those are some of the challenges. We're going to leave the last one, the hard challenge, open. That one was a little. That one was actually more direct than the interest one. So Phil's torture is over at this point. If there's really quickly any last minute questions that you guys have in the chat room, please post them. We'll give you about 30 seconds for the audio to catch up, and we'll see here. Waiting.
Nope.
So the grades for the project challenges, Phil and I will be doing those this afternoon if we have time. So some of you should start seeing those tonight. We will definitely get those done by Thursday at the very latest, I believe. So that should, hopefully that answers your question. Okay. I think that's all the questions. If you guys have any more questions, go ahead and post them in the discussion boards, and we'll see you guys in another 2 weeks when we'll do another one of these sessions and hopefully answer some more questions that you'll have. Thanks, everybody.